Leaping straight in, why do you think that construction technologies and digitalization within the industry has started to accelerate?
For many years, the focus has been probably more on the engineering side, how we fix that piece of the puzzle. Because it was very centric around that, I think the construction aspects of construction technology or Comtech, whatever you want to call it, was probably slower to evolve because people were really thinking about, how do we deliver the engineering a lot quicker and faster in the process, because that's typically the main focus at the beginning of the project is, how do we engineer it correctly? How do we remove the mistakes, so that out on the job site, things will go together smoothly and we can compress those schedules down. I think with a lot of education over the years, people have seen, how we can start to apply that digitization out into the other processes on the job site. And in all reality, the engineering aspect is only a very small percentage of the overall job cost. What I've started to see is people now thinking about taking that digital information in more of a clever way, let's say, just to be kind of simplistic about it, but rather than run around with a set of drawings, start to see how we can utilize that information and link it up with hardware that is actually doing the execution work on the job site itself. Whether it's in pre-construction stage or during the phase of construction or even post-construction or throughout that process for quality control and checking.
How are you seeing attitudes towards data change? Because that's got to be one of the real benefits in terms of the type of data you can get, how you can use that data, how you can react or use it to predict.
Machine learning has been something that's been talked about probably the last 4 years or so. That obviously moves you from one phase of data collection and then having your programs learn repetitive tasks. And then we start to throw in algorithms where we start to move in that direction of AI. So you need all of that information to get to the next point. So the first part is the data collection, understanding what we do with that data, how we're going to apply it into a machine learning practice, and then how can we start to build algorithms to help us develop something automatically, and look at different iterations.
Are you seeing people within organizations really start to explore the potential?
I think the larger companies, larger engineering companies, I've seen where they've used predictive models when we're looking at how building utilization is going to be, the flow of people, the flow of traffic, running different models, what the bottlenecks would be in a particular building, how that works in relation to fire and safety and everything else. So designing spaces around people, we see, I've seen a lot of that the larger engineerings are using. If you look at the Museum of the Future, they applied the data to design the building in itself with lots of different runs, thousands of different models to come up with the optimum design, weight, spacing of that structure. We have many companies that apply and put together different technologies, whether it could be linking to our structural modeling platforms, but then linking in to other algorithmic type softwares where you can build logic and let it automatically run. Human being, of course, to do that in a manual method would be near impossible, but to build logic and then let the computer do the work, that speeds up the process immeasurably.
Are there other examples that you've worked on where you think this just couldn't have happened without advanced digitalization and construction technology?
It's becoming almost commonplace that every structure will have some form of 3D modeling, whether it's architectural, structural, or the MEP side. But the coordination of those obviously have to go together to make a success. Other examples, if we look at the museums, Guggenheim's coming up, so that was certainly due to the complexity and nature of the building. We'll be using 3D technologies. Even straight up simple structures deploying this type of technology nowadays. So it doesn't necessarily have to be the complex, but it can be simple forms that are going to be using that type of technology.
For a simple building to employ that sort of technology, why would they do that?
Again, it comes down to the efficiency gain and the accuracy. So we move from, we think of a regular tower block, and years ago it was done in a more traditional 2D methodology. Traditional drawing seems simple. It could be beam and column type work, but at the end of the day, the inaccuracies and over measurement and over quantification that can creep in because people are trying to apply a rule of thumb method where technology actually does that for you. Sustainability is a big driver as well. So, people need to be much more accurate. We can't, just ship concrete trucks to site and then, just pour as we need. There's a carbon, impact to that as well. So I think there's a drive now, certainly here and globally, that how can we make more efficiency on the buildings that are going to reduce down the carbon footprint. So that process of only using what you need to use, using the right materials, using those efficiently, are really driving the need where you go to a simple one to actually have other gains associated to that.
Sustainability or demands by clients, by banks and financial institutions who are funding builds. I think that's really going to drive greater demands around sustainability and understanding your carbon footprint, being able to measure it properly and know, what your embodied carbon is, and to know what kind of efficiencies are going to be in place once the building is operational, etc. So actually, I really think that sustainability will be a catalyst to push more use of different forms of technologies in the future, because it would be hard to achieve that without them.
The embodied carbon, is a good point, because we could even start to look at from material to site, you're obviously producing a carbon footprint. So ensuring that, you have those distances between where we are shipping to and from, as well as the embodied carbon with what materials we're using, all go towards actually reducing the overall cost and expense that, that is going to have on the environment.
And is this something that you're increasingly seeing people ask for, the ability to be able to understand that when you're working with them?
From our point of view, we offer solutions and technologies that we're looking to reduce the overall impact on the environment. And it's, we can just think about a building, but beyond that, even at the early stages, how can we reduce down the fuel that's going to be used to prepare and do the construction site? And so if we look at the heavy equipment that goes on site, how can we use that more efficiently? And not having a truck go A to B to C, all the way through, when it can go from one place to the other and do its job. And so actually pre-planning and having machine control built in on the equipment itself is, one of the things that we've been pushing with our other division in the region for many years. There is still a resistance in that, unfortunately. If we look at other countries around the world, take North America and Europe, they're very conscious on that side. Over here, they would see the cost of investment in that type of technology. They would think that was very expensive. But in reality, when you've got, let's say, 40% saving in the cost of fuel over a course of a project, it pays back in a very short space and time. From an assessment that we did, various solutions, we've looked at saving greenhouse gas emissions by 550,000 tons per year on applications of different technologies. And some of those measurements are done based on equipment, for example, pre-fitted versus what the savings were post-fitted. So, we're thinking about millions of pieces of equipment waking up every day. That can have a global impact in a big way by applying, technology that's going to help be more efficient and plan the day, and see where underutilization is as well in those machines, because you want the machines to be running at their premium as much as the time as possible. So if we have problems on site and we need to address something, we could redirect that equipment elsewhere, while we're fixing whatever the issues are.
You mentioned opportunities not just during the build process, but post-build, once a piece of infrastructure has been handed over. What do you see as the chief opportunities there?
In terms of the post, applying solutions that can help better building control. So we're looking at the BMS type systems, for example, building management systems. The construction phase would be using augmented reality to make sure things are placed on site properly. Space utilization, is done in the correct way. And the post phase would come down to operations and maintenance in the future, and the longevity of that building.
You talked about how you're seeing attitudes changing, how some of these technologies are being used now, or how technology is being used increasingly now. What do you think are the big future opportunities? Where in the coming years do you think you'll see a lot more questions or push from client or consultants to use particular types of technology?
Our whole ethos is transforming the way that the world works, but through applied digital technologies. So there's many different creative ways that you can put together these different solutions and come up with something new. But AI is certainly the big focus area for many companies, and certainly we're looking at automation on the job site. We've been researching that for quite some time. We have some interesting examples where we can have heavy equipment driving autonomously on the job site. We've got kind of semi-autonomously and fully autonomous. So the semi will be a remote operation center connected to heavy equipment. And this is used quite often in the heavy mining industry, where you have these really big loader trucks, and it's quite a hazardous job site to be on. But you can remotely control equipment from a kilometer away, with it having fitted cameras and sensors and so on. And that application of AI through camera connectivity is identifying hazards and areas that the machine would automatically warn the controller of a crane, for example, that be wary there's something going on the job site. So that AI is going to be, I think, a big leading factor in the way that things are moving. And it really comes down to the data set that's behind of that, and then applied hardware technologies, partnering with a lot of other creative companies to club together these different solutions to come up with new creative ways of applying technology on the job site. Do we see a lot of companies applying that technology at this point in time? No. We do see a number of different industries doing it. And worldwide, we have a lot of different companies trying to use robotics as well on the job site.
The teaching that must go on for the AI to be able to spot and understand potential hazards on the sort of application that you've just described must be enormous.
What goes behind of it, is looking at teaching the robot or that application what would be hazardous. For example, is it a person on the job site who hasn't got safety gloves on, in the simplest example? So the camera will be looking for that, or whether they don't have their hard hat on, or whether they're in an area that's geo-zoned that nobody should be in. So that, and the camera obviously is looking out for movements and situations that occur. But that then is obviously then connected to a program that's going to signal somebody that there's something going on.
Introducing a lot more safety on site then as well.
Yes, exactly. Yeah.
People want to protect what they see as their intellectual asset, and that can hold back sometimes greater advances, because there's not that sharing of ideas or that sharing of approaches that can then be, I guess, amalgamated into a new piece of technology or a new approach that can be used within construction. So is that something you think there is that need for more talking, I guess, in construction?
Yeah, I think more talking. If we look at independence or universities setting up think tanks, we have worldwide a lot of different Trimble technology labs where we'll donate lots of different solutions, hardware, software, and let the universities look at the different approaches. And a lot of people are writing different papers, and out of that can be born the new phase of technology that can be applied. When it comes down to, yes, companies are, like you say, wanting to protect their IPR, and some will, for example, develop internal solutions that could be very advantageous, but they want to keep their edge above, over their competition. Why should I tell somebody how I did it better and quicker? Because I want to win that next job. So, and I don't want to give too much away. That is always going to be there, right? But I think more companies need to look at the examples in the industry and think, they've done something differently, and then talk to the providers and say, how can we remove these pain points and, improve our workflow? If we look at projects that, are in construction now, if we take the DEWA headquarters and other companies, they started to really apply different technologies because they've seen successes that have been going on in the industry, and they're saying, well, I want a piece of that. I want to make the most sustainable type of construction. How do I do that? And then we will consult with them, and we have done, and we do on various technologies, whether it's ours or something else that we could recommend. At the end of the day, we are happy to work with parties outside of our organization. Of course, we have a vast array of solutions, so normally we can deliver upon that. But it really comes down to companies are now wising up to the fact that there are mandates in our region to achieve certain targets and goals, and how do they go about doing that?
Well, thank you for your time.